it's a great pleasure to be here. And I'd like to ask the audience just a couple of questions, just so I know what I'm dealing with here. How many of you are good at checking your physical health? You know, you've got your Fitbits, you're counting your steps, you're monitoring things, maybe even your heart rate, as we've just been hearing about some things. How many in the audience use these sorts of gadgets to? Yeah, quite a few of you. So how many of you actually think very much about your brain health? Well, that's good. Quite rightly, you should. Okay, well, that's great to know. So I'm really pleased that you're all thinking in the right directions. So I'll start by just talking about some of the aims of what I want to do tonight. And one is to illustrate some of the work I've done in innovation to have impact in mental health. I'm also going to discuss the increasing lifestyle use of cognitive enhancing drugs by healthy people. And then finally, I'm going to discuss some evidence-based methods for mental well-being. So I do a lot of neuroscience and mental health policy, both for the UK government, but also around the world. And one of them is the Grand Challenges in Global Mental Health that we've done fairly recently. And I've just been working on one for the Department of Health, which is a 10-year strategy for the framework for mental health research. And all these policies, recent policies, have really been looking at how can we detect problems early in mental health, and how can we give effective treatments? The other thing that they've all focused on is cognition, the way we think, the way we, our thought processes, our attention, our memory. Cognition is an important target for treatment. And of course, this is true because cognition is very closely linked to well-being. So the better your cognition, the better your sense of well-being. Also, really, you have no health without mental health. I mean, when you look at any kind of disorders, people who talk about them will say it's the cognitive problems that are the most difficult for them, not the physical problems. So cognition is really very important. So I'll ask you another question. How many of you are functioning at your optimal level tonight of cognition? Oh, that's good. There's a couple of you in the audience. It's getting a bit late on, so maybe the peak was a bit earlier in the day. But many people have sleep problems and other problems, and we're not always functioning as best we can. And many of you here probably travel around the world as well, and so you might suffer from jet lag when you get someplace. So a lot of my work with policy is really focused on shifting the paradigm from trying to treat people who've been ill for a very long time and have chronic relapsing mental health problems to looking at prevention and early detection, and also how we can boost cognition in healthy people. How can we have the best brains? And this is very important because, of course, we're in a knowledge economy and we've got to compete with artificial intelligence now. So our human brains have to work as best as they possibly can. And the other side of things is I've been very interested in early development and looking, because it's such an important phase. We now know that our brains are still in development well up until late adolescence, early young adulthood, about age 24, 25, the front part of the brain, which is, of course, very important for all our higher cognitive functions, like planning and problem solving, doesn't develop till very late. So it's really important that early on we look at what's happening so that we can have, make sure that people's brains are developing as best as possible and that they have resilient neurodevelopment. So this is one of the projects I worked on, the UK government foresight project on mental capital and well-being. And really what this was, the focus of this project was that the UK government had two major problems. One was that we have an aging population in the UK, and of course age is a big risk factor for Alzheimer's disease, and they were worried about, how are we going to keep our brains at peak peak functioning as long as possible throughout into old age so that we don't have dementia. And the second problem they had was that businesses were losing a lot of money due to days lost at work due to depression. So they wanted to know, how could we make sure people had a good sense of well-being so that they could recover if they did get depressed, recover quickly, but hopefully prevent it altogether. And so in this project, we went through a whole lot of factors that promote well-being, and those are the blue ones pointing upwards. And there's such things as a good education and so forth. And then we looked at the things that detract from mental capital and well-being, and those are things like stress or substance abuse, and those are in the red pointing downwards. And so we focused on that. Now, for most of my life, I've worked on Alzheimer's disease, and it's a very important, as you know, disease, and almost everybody in this room will probably have had a relative that has had Alzheimer's disease. Well, the problem with it was, and is that in order to get a diagnosis, not only do you have to have a memory problem, which is how it starts, you first see memory problems, but you have to have another type of problem in another different domain, such as language or motor sequencing or naming. And then on top of that, it has to represent a decline from your previous level of functioning. And that decline has to be sufficiently severe that it affects your occupational or social functioning. Well, clearly, by the time you have all that happening to you, it's a very advanced stage, and you've already lost a lot of well-being because you can't perform at work, or maybe you can't do your duties within the home. And of course, while brain scans and other techniques are very useful for diagnosis, we use these brain scans now. We can image in the brain, we can image the amyloid and the tau protein, which are the neuropathological changes that we see in Alzheimer's disease, but they have to be accompanied with a change in cognition, a decline in cognition. Well, we do know quite a lot about the neuropathological basis of the cognitive problems in Alzheimer's disease. And what we know, for instance, is that early on in the disease, you get destruction of what we call the basal forebrain, and that leads to loss of acetylcholine, the chemical in the brain, acetylcholine, throughout the cortex. And that means when this happens, it means your attention is affected, so you lose attention and concentration. And the current drugs that we have that are NICE approved that the NHS can give you when you have Alzheimer's disease are cholinesterase inhibitors, and they essentially boost acetylcholine in the brain, and they improve your concentration and attention. And I worked on those drugs very early on and published the work in the LANCET, and what we showed was that in mild Alzheimer's disease and moderate Alzheimer's disease, you could get improvements in attention and concentration with these cholinesterase inhibitors. You probably know them as Aricet or donepezil. But we weren't able to really affect the major problem, which is in episodic memory. And cell loss in the hippocampal formation is what causes the episodic memory problems. And those episodic memory problems are everyday types of memory, the sort of memory that, where did I leave my car in a multi-story car park when you come back several hours later and you're thinking, I parked it here somewhere, where is it? Or, you rush into your house and you leave your keys somewhere, and then later you want to go out and you're looking for your keys. That's episodic memory. And then finally, we get cell loss in the neocortex, temporal neocortex here, and that affects our semantic memory, and that's knowledge for facts, knowing that the President of the United States is Mr. Trump. Who could forget? So the key to optimal treatment, as I said, is early detection. Now, I see many people in the audience, they look in their 20s, and of course you're functioning at your peak now, so enjoy your cognition while you can, because you're at your peak performance. The rest of us are slowly declining in this normal way that happens with age. Now, currently what happens is you get a diagnosis of Alzheimer's disease, and they can treat the symptoms with the cholinesterase inhibitors, like the Aricept and Epizil, and they put them in here. But drug companies are really trying to work on identifying and then treating the underlying disease process. And of course, when they have neuroprotective drugs, you want them in here so that you don't have a decline, so that you can still stay at work and enjoy a good quality of life within your family and at work. And there have been cost-benefit analyses, and it is already shown that within the NHS, if you treat early with these drugs that we currently have, you do save a lot of money. It's also good for the person, of course, because most people want to stay in their own homes. They don't want to go into institutionalized care. And what's been shown is that these drugs will keep you out of institutionalized care for longer. But we really need better drugs that will actually treat the early episodic memory problems that we get. And first of all, we need to detect when somebody's getting a memory problem. And so, together with my colleagues Trevor Robbins, we invented a set of tests called the CANTAB tests. And they now run on these mobile tablets that you can see here. And they're FDA and EMA approved by the regulatory bodies for drugs. And they're used in over 800 universities, research institutes, and hospitals. And so, this is a good advance. And through Cambridge Enterprise, we've tech transferred these to Cambridge Cognition, the company, and they're sold via that company. So I've mentioned what episodic memory is, and it's you go into work or whatever, and you park your car in a multi-story car park, and you come out later and you think, where did I leave that car? Or where did I leave my keys? And you can imagine how disruptive it is if you can never remember where anything is. So it's a very important function of everyday memory. Well, how do we measure it in the laboratory? So this is the test that we've devised. And it's really based around what the hippocampal formation does, because that area of the brain is the first one to get the plaques and tangles, the neuropathology in Alzheimer's disease. So understanding what the hippocampus does and how we can measure what it does is very important. And the hippocampus helps us navigate through space, and it helps us find the location of objects in space. So this is the way we simply test it. We give you an iPad, and you could be in a GP surgery or wherever, and I just simply say to you, what I want you to do is to look at this and remember where each of these objects goes. So you can see this one here. Remember where that is. And remember where that is. Remember where that is. Remember where that is. Remember where that is. And remember where that is. So I hope you all know where these are now. And so you probably remember, hopefully, that it was up here. Now, it's quite difficult, you can see, to do that, but we give you several attempts. So if you don't get it the first time, you have several attempts to learn it, to learn where these things go. And we also have easier versions where there's only four items in these 6 boxes, and then we have very difficult version where there's 8 boxes come on the screen, and you have to learn this. But this 6-box version is very sensitive to Alzheimer's disease, incredibly sensitive to picking it up. And healthy people are very good at learning this quite quickly. And over the years, we've demonstrated all this, these publications and so forth have demonstrated that it's sensitive to Alzheimer's disease, sensitive to mild cognitive impairment, and so we've gone through all the studies that you need to do to demonstrate its utility. So now it's available for GP surgeries, and it comes in, the instructions just come in 20 languages. It's very easy, as you can see. You don't need much instruction, but they are in 20 languages. And for a busy GP, you can just get an answer, a green light that says, this person's fine, there's no need to have them investigated any further. Or you can get an amber light which says, keep monitoring them. Or you can get a red light which says this person has a poor memory and they should be investigated further. And the nice thing about this is the data comes back in the cloud, so you can actually use it for public health reasons to monitor how many people in different areas of the country are developing dementia. And you can see how many people were tested and how many people were found to be impaired. We're currently using it in a study where we're hoping to find new drugs for Alzheimer's disease, especially to treat the underlying process. And we've got a number of different biomarkers that we're studying. So some of them are PET biomarkers and positron emission tomography biomarkers, neuroimaging biomarkers. And then we're using this CANTAB PAL test as well. So, and by using that test that I just showed you, the CANTAB PAL, it's been used in a very large study in Europe where they looked at Alzheimer's disease. And they studied the very early stages of Alzheimer's disease, which is called mild cognitive impairment. So it's before you get the diagnosis of Alzheimer's disease, but you've still got these symptoms. And what you find in Alzheimer's disease is you get shrinkage in the hippocampus, and also you get increase in tau. And what you can see here is that the performance, how well you do on the CANTAB, relates to how large your hippocampus is. And also, if you're doing very poorly on the CANTAB, then you have more CSF tau, so more of this neuropathological marker. We've also put people in the scanner to image them, and we put healthy people in the scanner, and we put people with mild cognitive impairment, the early stages of Alzheimer's people, in the scanner. And what we've been able to show, I showed you the 6-box level, that's the one you did, of the CANTAB PAL, but there's the easier 4-item version, and the more difficult 8-item version. And you can see here the hippocampal formation is activated when you do this task. And with healthy people, they don't really have to activate very much when there's only 4 things in the boxes because it's relatively easy for them. But when there's 6, the activation in the hippocampal formation goes up and it stays up for the 8. What you can see with the mild cognitive impairment patients is that they're maximally activating the hippocampal formation at this point, at 4, and then they find it too difficult, so the activation goes down. Now this imaging provides a model system because if we could only change this line to look like this line with a drug or some other form of treatment, it would be excellent because we'd be able to normalize the performance in the brain. Well, how can we boost episodic memory? So one mechanism we've been doing, one way we've been trying to do that is through what's called cognitive training. And it's a technique that psychologists have used, which is simply to put somebody in front of a computer and get them to perform episodic memory tasks until they get better and better at it. And this works well, but the trouble is that people find it extremely boring. So you can't get people to do it for very long. And when they don't do it, of course, they don't improve. So what we decided to do was actually make it a game. So we thought, well, everybody plays games on their mobile phones. Why not do a game that's good for your brain? Boost your episodic memory. So I put out an advert for a games developer to come into my laboratory, and I got Tom Piercy, who'd been working on betting games mainly for the betting industry. And he said he'd like to do something more socially responsible, so that was good. So he came to work with us, and we sort of showed him how we wanted to improve people's memory, what they needed to do, and he made it a game. And we thought, okay, well, how are we going to do this? So with older people, we used a game show theme, because a lot of people like to watch daytime TV and they like to watch the games that are on daytime TV. So we use that type of thing. And with younger people, we used a Harry Potter wizard theme because we thought that they'd like that, and we found out that they did, in fact. So we did 2 separate studies. And we actually collaborated to get the test to work. It took about 9 months between the psychologist, neuroscientist, the games developer, and also the people we were targeting. So in this case, we were targeting people in the early stages of Alzheimer's disease with mild cognitive impairment. And in this case, we were targeting people with schizophrenia because they also have poor episodic memory. So we needed to make sure that they got it, that they didn't have to be told, instructed as you do if you're sitting with somebody and you're giving them cognitive training. A game should be fun and you should get it right away. So we had to work on it for quite a while to make sure that it was easy to understand and it was fun, and then they got the benefit from doing it, which was great. And of course, it makes it much more motivating, which is important. So with Game Show, we actually had people train for 8 hours over 1 month, and they played the game for 8 hours over 1 month, and these were people with mild cognitive impairment. And what we were able to show was that after that time, the people who had trained were much better than those who had not had any training and just had their treatment as usual. So we got improvements in the training group. We also found that the people enjoyed it very much and stayed motivated through the whole 8 hours worth of gameplay. And it increased their confidence too, which was good. They felt better about themselves because they were getting better at the episodic memory game. Well, I also work with patients with schizophrenia, and many of you are familiar with the sort of what we call the florid or psychotic symptoms of schizophrenia, such as the delusions or hallucinations, so hearing voices or having unusual thoughts that you rule the world or something like that. Well, these psychotic symptoms are reasonably well treated by the antipsychotic drugs or neuroleptics that we have. They're D2 blocking drugs. They block dopamine receptors in the brain. And they work reasonably well to dampen down the delusions and hallucinations. But people with schizophrenia have two other problems, and they're unmet needs. There's no treatment for them. One is the impairment in cognitive function. And many of you might have known somebody who, was a friend or was at school with you who then, developed schizophrenia and couldn't continue on in school, or was in university, developed schizophrenia and then had to drop out. And this is because of the cognitive problems, not because of the hallucinations and delusions. So it's the cognitive impairment that they suffer that causes the inability to really rehabilitate, go back to university, go back to school sometimes. And the Food and Drug Administration in America has recognized that cognition is a target for treatment in schizophrenia because of the fact that it's so important for rehabilitation. But unfortunately, there's no medications currently available to treat it. Now, people with schizophrenia also have a motivational deficit. It's called negative symptoms. And that also hinders rehabilitation. It's hard to get their motivation up. What we were able to show is that their episodic memory is impaired quite early on, and that relates to their functional outcome. So there was a direct relationship between the performance on CANTAB PAL, the episodic memory test, and how well they did in their daily life, their activities of global functioning. Now, as I said, we know that cognitive training works for different patient groups, and it does work in schizophrenia. And it gives, if you train, you get a moderate effect size for cognition, and you also improve psychosocial functioning. So it isn't just that you're narrowly improving cognition, you also get effects on just the way they perform in their daily lives. However, the problem with cognitive training, as I said before, is that the dropout from treatment is very large. Some of the studies, the dropout is 20 to 40% of people drop out before they finish the training. And it's also very expensive to deliver because it requires people come into hospital. There's usually a specialist, like a psychologist, delivering it. So it's expensive as well. Well, again, what we did with the Wizard game was we had people play the game for 8 hours over 1 month, and they improved their episodic memory during that time, and they also improved their daily functioning by playing the game. And again, we didn't have any problems with motivation because the enjoyment stayed up. They really liked playing it. So this is the way we can use new technologies and innovation to actually deliver effective cognitive and motivational treatments to people. And it's inexpensive because you can just put it on an iPad. So we've transferred this to the games company in London called Peak, which is quite a successful company. It's won several awards. And now it will go on people's mobile phones. So it's available to download and just put on your phone and improve your memory. And so anybody who wants to have a go can just get hold of it that way. So we're currently using a lot of external collaborations with the CANTAB test, which we've invented, and one of them is the deep and frequent phenotyping study in Alzheimer's disease, which I mentioned. But we also, it's now part of the DP UK platform, so any drugs that are being developed for Alzheimer's disease, people will be doing this CANTAB test as well. And it's being used within the Sarah Tabrizi's group with Huntington's disease. They're using the test as well. And importantly, we've just submitted our first paper on this study of deep brain stimulation in patients with very severe obsessive compulsive disorder. And unfortunately, people with OCD, some of them become very ill, stay very ill for a very long time. And although people have tried to give them the usual drug treatments, which are selective serotonin reuptake inhibitors, the SSRIs, they don't respond to them. And people have tried psychological treatments, such as exposure, where you stick your hands down a toilet or something to try to get over the fact that you've got contamination and you're worried about it and that sort of thing. And they've had them in hospital and done both the psychological treatments and the drug treatments, and they've not benefited. So the last resort, because some of these people are threatening suicide or other things, is really to give this deep brain stimulation. And we were talking earlier that if anybody can manage to invent a way of stimulating deep in the brain without invasively sticking an electrode in, this would be a tremendous advantage, because at the moment we have to wait till everything else fails, and some of these people have been ill for like 20 years. But it's actually like a light switch. So somebody who's not left the house for ages, years, suddenly, after deep brain stimulation, goes out, gets a boyfriend, goes on holiday, and their whole life has changed. So it really is almost resetting the brain. So if you can figure out a way to do this without actually sticking an electrode into the brain, that would be terrific. So that's a challenge for somebody there. So now I'm going to talk about something near and dear to my heart, which is drugs, because I have a psychopharmacology laboratory here, and I work with these drugs, methylphenidate, modafinil, and atomoxetine. And methylphenidate, most of you know, is Ritalin, and this drug acts by increasing synaptic concentration of two of the chemicals, dopamine and noradrenaline, and it does this by blocking their reuptake in the brain. Now, Ritalin, as you know, is the most common treatment for attention deficit hyperactivity disorder, and it works in about, I would say, 70% of the cases. It works quite well. But there's about 20 or 30% of people that either don't respond to it at all, or where they can't take it because the side effect profile is too difficult for them. It also, of course, being a stimulant drug, has some abuse potential, although in the formulations that they give, and they all obviously give these drugs to children, it's, the risk of that is very low, but there still is some. There's another drug called Atomoxetine, and it's a more recent treatment for attention deficit hyperactivity disorder, and the reason some people like it is because it acts rather selectively on the neurotransmitter noradrenaline, and so it boosts noradrenaline rather selectively. It doesn't have any abuse potential, and so that's, people are keen on that, and that's because it doesn't have actions on dopamine in the brain. And then there's another drug called Provigil. Now, Provigil, we're not actually sure how it exerts its cognitive enhancing effects, but it seems that it's probably also through noradrenaline, boosting noradrenaline and dopamine in the brain, but it probably also has actions on glutamate indirectly through its actions on another transmitter, GABA. Now, Modafinil, or Provigil, is used for narcolepsy, excessive daytime sleepiness. And so I always tell the audience, so if you fall asleep, well, maybe it's just late in the evening, or maybe, you know, you're not interested in my lecture. But if I fall asleep, then that is narcolepsy. And in America, it's also used, regulated for sleep disturbance due to shift work, because it's been found to reduce accidents in shift workers. And interestingly, I mean, people have talked about the classic stimulants like amphetamine, Adderall, and methylphenidate, Ritalin, as being, you know, a stimulated vigilance, whereas modafinil is more calm wakefulness. So I'm going to show you another one of our tests, and it's a test of what we call working memory. So working memory is incredibly important because working memory is embedded in almost any what we call executive function test. So the frontal lobes are responsible for our higher level cognitive functions, planning, problem solving, that type of thing. And in all those sorts of cognitive functions, there's a component which will be working memory. And I often explain it to people by saying, you know, when you put a talk together like this, you might pull some information together and you'll be using it and working on it. And then perhaps you'll decide, oh, it doesn't fit with this theme of the lecture, so I'll throw it out. And then you forget all about it. So you only keep things in that working memory for as long as you need them. And then you chuck them out. In the old days, it used to be easy to explain it by looking numbers up in a phone book, but we don't do that anymore, so it's not so easy. But I'm sure some of the older people in the audience will remember when we did use phone books, and you looked up a number, and you'd verbally used your working memory by saying 01223 365878 or something like that, and you keep repeating it till you dialed the number, and then you'd close the phone book, and it was fine if you got through. But if you didn't get through, you couldn't remember the number anymore because you purposely had chucked it out because you didn't want it in your working memory anymore because you didn't think you needed it, but you didn't realize, you know, you were going to get a busy signal or something. So anyway, the other thing about working memory, which makes it so important, is it's related to IQ. And it's related to both what we call fluid intelligence, which we think of as creative intelligence. It's also related to crystallized intelligence, and that's what we measure when we use the Wechsler Adult Intelligence Scale, or the IQ test. So the idea being that you've got this nice relationship between both the fluid intelligence and crystallized intelligence, so one hopes that you might be able to, if you can boost the working memory, you might be able to boost your IQ. And working memory is also affected in many neuropsychiatric disorders, including attention deficit hyperactivity disorder and schizophrenia. So again, it would be a way, if you could boost that, it would be very useful for these people who have cognitive problems. So here's a test of working memory. Again, a very simple test. What I ask the person to do as they're sitting in front of an iPad is to search through these red boxes to find a blue square. And when they've found the blue square, all they have to do is move it over to this column here. But the important instruction is, once you've found a blue square inside a red box, the computer will never hide it in that box again. So never go back to a red box where you found a blue square, and if you do, that's an error. So you start by just touching a red box to open it and see whether there's something in there, nothing in there, nothing in there, nothing in there. Oh, blue square, good. So now you move it over into that column. And now you know never to go back to that box again. And if you do, that's an error. So you start your search again, and you know to skip over the next box. And that's how working memory is. That's how you test it in the lab. And what you could see is that spatial working memory is very impaired, both in children with ADHD and also in adults with ADHD. Now, some of you might not realize, but about 50 to 70% of people who had ADHD as a child still has it as an adult. So there are now a number of clinics that treat adult ADHD, and they wouldn't be able to hold down jobs if they weren't treated because they wouldn't have their planning capacity and know to go to work on time and things like that. So it's very important that they get treated if they have a problem. So methylphenidate improves spatial working memory in adult patients with ADHD, but also you can see in our laboratory, it improves it in healthy volunteers as well. And these are Cambridge undergraduates, so they're pretty bright, and they're not sleep deprived, but they're still getting improvements. Well, we can put people in the scanner out at the Wilson Brain Imaging Center up by the hospital. And what you can see is that what methylphenidate does is not only does it improve the working memory performance, but it increases the efficiency of the dorsolateral prefrontal cortical circuit that's used. And we could see this by testing healthy volunteers. So you get an increased efficient circuit. And basically what that means is your brain doesn't have to work as hard and you get a better performance. So that sounds like a good thing, doesn't it? Well, we've been interested in whether methylphenidate works differently in people with ADHD compared to healthy people. And we've done these PET studies, and what that's shown is basically it's working in the same way exactly. And what we've also shown is that low performance tends to be very much improved by methylphenidate. So if you're not very good at attentional things, sustaining your attention, it will be improved by methylphenidate. If you're already doing quite well, it doesn't go up very much. Looking at modafinil, we've also found that it improves working memory in healthy volunteers and in patients with first episode psychosis. So you can see here the healthy volunteers improve, and here you have very difficult versions of the task. They get 10, and they have to find 10 of these tokens or 12. But you can see it also improves performance in patients, which is very good. And that was replicated in another study that was published after our study. And we've recently shown that modafinil also improves working memory performance in patients recovering from depression. Now, a lot of people who have to go back to work sometimes find that they still have problems of concentration. They can't concentrate, they can't learn new things or whatever the difficulty might be. And so we've been looking at whether modafinil might be an aid to helping them improve their cognition when back at work. Now, there's another test called stop signal reaction time test. And what this test measures is kind of your impulse control. And I'm sure this audience probably has perfect impulse control. But, road rage, things like that, or, I often say when I'm talking about a child with ADHD, they might be sitting there next to another child and the boy suddenly sees a ruler and he thinks, great, I'll pick up this ruler and I'll bop this kid over the head with it because I'm enjoying doing that, and starts bopping, bopping, bopping. And the teacher shouts, stop. So can the boy stop bopping away, or does he keep on bopping away? And that's really what this sort of thing is measuring. Can you actually inhibit your responses and control yourself, or is it that you have no impulse control? And what you do in this task is that you have these arrows come on very quickly on the screen, computer screen, and some point to the right and some point to the left. And you just are told to press as quickly as you can on your right button if you see a right arrow, and on the left button if you see a left arrow. And that's all you have to do, but do it as quickly as you can. And as you're doing that very, very quickly, all of a sudden you hear beep, and then you have to stop. And so you've started your response, but you've got to try to inhibit it. And what you see here is that Ritalin can improve inhibitory control in children with ADHD. And actually it does so well that it brings them right in line with healthy boys who haven't got any problems of ADHD. So it really is a good treatment for impulse control. Now, atomoxetine improves response inhibition, but it doesn't have much effect on spatial working memory or sustained attention. But you can see that in these adults with ADHD, it is very good at also improving inhibitory control. Interestingly, atomoxetine does the same thing in healthy volunteers. So it is very good at improving your inhibitory control in healthy volunteers as well as in patients. So these drugs are basically acting the same way in patient groups as they are in healthy controls. And modafinil can also improve response inhibition in healthy volunteers and adults with ADHD, as you can see in this slide. So these are all double-blind, placebo-controlled studies done in my laboratory, so it's very clear that the person doesn't know whether they're taking the drug or not, so these effects are very robust. And I've been talking about what I call cold cognition. So that's non-emotional cognition. It's like the type of PAL test that you saw. But there's also what we have called hot cognition, which is emotional cognition. So it's a sort of thing where if I look out at this audience, I can see that people are looking at the screen or they're making eye contact with me, and that gives me good vibes. I'm feeling really good about that. But if I had depression, for instance, I might look out at the audience and see one person who's dozed off or somebody else who's checking their phone, and I'd think, oh, this isn't going very well. I'm not doing very well because, you know, just one person out of the whole audience is looking at their phone, and that's what happens in depression. That's hot processing that goes on and goes badly wrong. So we have in the brain, it's interesting, you can actually, it's a whole different lecture, but you can actually put somebody in the scanner and give them a test of cold planning, such as, you know, sort of figuring out your schedule for the day or something like that, and you get the circuitry in the brain, and particularly dorsolateral prefrontal cortex, which is kind of up over here. Or you can give them a hot problem, an emotional decision-making problem, maybe a risky one where they have some betting to do, and then you get orbital frontal cortex. And orbital frontal cortex has strong links to the emotional brain, areas like the amygdala. And orbital frontal cortex is kind of just up here behind the eyes. So you actually have these decisions, which are cold or hot, are made in different, slightly different neurocircuitry and areas in the brain. Well, we've been able to show that modafinil also improves the recognition of emotional faces, so it can improve hot cognition, because emotional face recognition is a type of hot cognition, and modafinil is able to improve that too. And the CANTAB tests primarily deal with what we call cold cognition, but we've recently designed tests and invented tests for emotional processing and social cognition. They look at impulsivity and reward sensitivity, things like that. And those are just being developed, and they're just recently been tech transferred by Cambridge Enterprise to Cambridge Cognition. So they'll be launched very shortly. So I'm going to finish off by talking about the increasing lifestyle use of these drugs. And methylphenidate's certainly on the increase, and it's been being used for a long time. And I think this professor sums it up quite well from the University of Wisconsin. He says, so for students who have put off work or are not very strong academically, we find some of them are using it to kind of counteract or remedy their problems. And the Care Quality Commission over here found a rise in prescriptions of methylphenidate in England, and the increase was over 50%. And interestingly, they attributed it to three different reasons. One was that, it's quite a good reason, that ADHD is being identified more in children and diagnosed and treated effectively. And a lot of people have had very poor school experiences because they weren't diagnosed and treated, so they couldn't take in any information, and they caused problems in the schoolroom, and many of them dropped out and so forth. And it has been shown that if you don't treat severe ADHD with a effective medication, what happens is many of these people will end up in prisons or have more accidents or things like that. So it's important to treat when it's a severe ADHD. The second reason was that we do now realize that many adults still have ADHD as an adult, and we used to think it disappeared when they went into adolescence, but we now realize that it just continues and changes a bit. Instead of running around and being, very active, a lot of it is inattention. They're not able to focus their attention and keep their attention. So it's the drug treatments are being used more for adults with ADHD. But the third reason, interestingly, is due to its potential for diversion and misuse. And when I've lectured at different universities, I often hear students say before exams that I don't want to use these drugs, but I see other students using them, passing them around in the library and so forth. And so this is what they mean by the diversion and misuse, and it should be monitored. And these are a number of surveys, just so you can get the idea of the percentage of people using these drugs. When Nature did their survey, they found about 20%. When they did a survey here in Cambridge, they found about 10%. The Oxford survey came up with about 15 or 16%. And so you can see that it ranges, but it's still perhaps somewhat surprising at the level that it's being used. And you can also see that modafinil is being used a lot off-label by healthy people. In fact, it's been estimated that maybe 90% of it is being used off-label. In Germany, they did a survey of workers, and they found that it was on the increase in the working population of Germans. This was an insurance company, and they found that a lot of people were using it just to be able to do their work. They felt they wouldn't be able to do their work effectively if they didn't take the drugs. So some years ago, this is Danny Turner, who was a PhD student at the time, and she looked at modafinil improving planning in healthy people. And of course, it is very good at improving these higher level functions. You can see that whether you had the 100 or 200 dose of modafinil, you did much better than being on placebo. And some of you may have heard about the recent study where they looked at chess players who were on modafinil, and they found that modafinil improved performance in the chess players when the game was not timed. But what they found was that it tended to make people think longer, they performed better, but if they ran out of time, then they would lose the game. So we also found in our study of planning a very similar effect. So we found an improvement in accuracy, but we did find that they took a bit longer to do the planning problem-solving task that we had for them. So I've been very interested from an ethical and societal point of view about why are healthy people using cognitive enhancing drugs. And some people have written to me and say, I use them because I want to be the best I possibly can. I'm not competing with people, I just want to be really good, and I want to be at my optimal level all the time. Other people do use it for the competitive edge. The use of it goes up a lot around exam time, both because people have to stay awake and alert because they haven't studied for the exams and they're trying to stay awake, and also because they take it during the exams. But some of them use it in a very counterproductive way because they take, for instance, Ritalin, and then as it starts to wear off, they take another pill, and then they can't sleep at night, or they work through the night, and you're supposed to consolidate your memories in your sleep, so it's a little bit counterproductive because you're not sleeping when you should, and obviously sleep is restorative as well, and you do need to consolidate your memories. My colleagues use it to counteract the effects of jet lag. I first found out and started getting interested in healthy people using these drugs when I was giving a lecture in Florida. And it was late in the day, and I was a bit tired and everything, and I turned to my colleague and I said, he was a psychiatrist, and I said, you know, I'm really tired. I wish they had given me a morning slot. You know, here I am in Florida, and it's like, you know, goodness knows what time it is over in the UK. I'm really tired. I wished I'd spoken early in the day. And he said to me, would you like some of my modafinil? And I said, oh, do you use modafinil? He goes, yeah, I use it all the time for jet lag. So then we had a little tea break, and we were sitting out drinking coffee and tea and so forth. And I sort of said, so is anybody else using modafinil? And somebody said, yeah, I use modafinil. And then somebody says, no, I use Ritalin. And then somebody else said, oh, no, I use Adderall. So it seemed like the whole table, except for me, was using drugs. So it's quite common, I think, for a lot of the medical profession to be using some of these drugs. And then another important reason is not only they're using it for these staying awake for longer periods of time and so forth, but another reason that we found was those tests I just gave you, when we gave them to healthy people and they were on modafinil, we asked them to rate how much fun was it to do the CANTAB PAL test and how much fun was it to do the working memory test. And you can see under placebo it was okay, it wasn't too bad. But under modafinil, it was great fun, really pleasurable. They really enjoyed it. So this is like, it gives you an increase in what we call task-related motivation. It's really a work drug. So we also asked them about, you know, euphoria. You know, we wanted to know, you know, is it any interest in it recreationally? But it wasn't, no euphoria, just task-related motivation. And also, with modafinil, nobody's actually demonstrated any abuse potential. So unlike the classic stimulants, there is no demonstrated abuse potential for modafinil at the doses that you'd use it for cognitive enhancement anyway. Now, recently I wrote an article with my colleagues for the conversation because there's a new thing going on. I don't know whether you've all heard about this, but in Silicon Valley, the trendies are all using microdosing with LSD. So they're using very, very low doses, about 1/10 of the recreational dose of LSD, and they're using it to enhance cognition, but really to enhance what they call creativity. They think it makes them more creative at work. And so this is yet another trend that's on the up. I'm not going to talk too much about pharmacogenomics, but you know, there could be a time in the future where we know that pharmacogenomics is a discipline between how our genes influence our body's response to drugs. So there could be a time in the future where, you know, you go in, you give your gene chip, they say, oh, well, I don't think you should take this drug, but you can have that drug. And this might be helpful for enhancing your cognition or whatever. We actually looked at it with ecstasy. This is when my student John Reuser was working with me for his PhD. And what we found was that people were raving at the weekends and taking ecstasy. But many of them were getting midweek lows, and some of them were getting actually depressed. And so we know that drugs which boost serotonin in the brain, the SSRIs, treat depression and they improve our mood. And we know that ecstasy used chronically decreases serotonin in the brain. So the idea was that perhaps with all this raving, you're actually decreasing the serotonin in the brain and actually inducing a kind of depressed state. And what we found was that actually this was the case, but only with people with the SS allele of the serotonin transporter gene. So it was the interaction of the gene with the ecstasy which was causing the problem. So I've been very interested in neuroethics. I was the president of the International Neuroethics Society. And neuroethics is the study of the ethical, legal, and social questions that arise when scientific findings about the brain are carried into medical practice, legal interpretations, and health and social policy. So what are the rights to using these drugs? Well, we might be able to get rid of unfair disparity in society. People should be helped if they could be helped. There was actually a doctor who's written up in the newspaper because he was giving kids Ritalin who weren't actually diagnosed with ADHD. He was actually trying to improve their cognitive performance at school and felt that they should be helped. And then other people argue for increased performance, that we should have better performances, both pleasurable and competitive. And obviously the military has used cognitive enhancing drugs for a long time. And as you know, in World War II, they were giving pilots amphetamines to stay awake and alert while they flew their planes, and they're still using these drugs. And then who might we want to improve? Surgeons, shift workers, air traffic controllers. What about elderly people? Are you enhancing an elderly person, or are you restoring them back to where they were when they were in their 20s? Maybe it's just restoration, because maybe you're just giving them the abilities that they had, but they've sort of lost over time. With Lord Aradasi, we did a study we published in the Annals of Surgery, and he was very interested in modafinil because his surgeons were taking a lot of coffee to stay awake and alert at night when they had to do complex operations. And because they took so much coffee, they were getting some of the hand tremors and other side effects that you get. And of course, you don't really want that in a surgeon. So he thought modafinil might be a better cognitive awake and alerting agent and be very useful. So we did a double-blind placebo-controlled studies, and we sleep-deprived doctors, and then we gave them either modafinil or placebo. And what we found was that modafinil actually reduced impulsive behavior and improved their cognitive flexibility in terms of their problem solving. So they were very fast at being flexible and solving problems, much more so than those who had placebo. So what are the concerns? I mean, should we be concerned? Well, first of all, we now know, as I said, that our brains are still in development right up until 24, 25 years of age. So what are the effects of putting drugs into a healthy brain? It's one thing if you've got a condition and you need to treat that condition in order to be able to have a good school experience or whatever, if you've got ADHD, for example. But what about a healthy, normal brain? What are the long-term effects? And so we don't really know, because nobody's done a long-term safety and efficacy study in healthy people. We really need to know what are the effects of these drugs in the long term. And then one thing I'm worried about is that, you think, okay, you take these drugs, you're more effective at work, more efficient or at university, and then you can have time for other activities that are important. You can do sports, or maybe learn another language or do something else, or maybe you see more of your family. Well, will we do that, or will we just accelerate into a 24/7 society? So now that we can work longer and harder, we will work for longer and we'll work all the time. So maybe we'll just end up without developing ourselves in any way and just working all the time. And then there could be greater inequality if these drugs cost a lot of money. Maybe only people who already don't really need them because maybe they have tutors or other things will be able to have access to them, but people who don't have wealth won't. And one thing that concerns people is, is it cheating using these drugs, especially in exam situations, which are competitive situations? And to my knowledge, Duke University is the only one who has put a statement on their website to say that the unauthorized use of these prescription medications to enhance academic performance is cheating. And one of my biggest concerns is that most people are buying these drugs over the internet. So a lot of students are getting modafinil from, these places in India, China, Russia, and they don't really know what they're getting. It could be anything. It just comes in the post. It might not be made under the sort of quality control conditions that you would expect from one of the large pharmaceutical companies here. So it could be contaminated as well. You don't know at all. So these are all very worrying. And the MHRA contacted me just as they were doing their seizure of a load of smart drugs in the UK. And they were able to do this because this website was actually based in the UK. They can't really stop these drugs from coming in from other websites based elsewhere, but this one was based in the UK, and these drugs were coming in from Russia. And surprisingly, this drug here, which was on sale, had actually never been tested on humans in clinical trials, but was being sold to people to cognitively enhance them. So that's a very worrying thing. So I wrote about these increasing lifestyle use of these drugs and ethical and societal concerns. And I also wanted to know a little bit more about how many people were using them and why and how. So we got together with Nature, and they did this survey. And, you know, I asked, there was a professor in America, and I asked him why he used it. He said jet lag, and he got it from his primary care doctor. And he thought he got a moderate effect with the drug. And he said it affected his attention, working memory, and word finding. This was a philosopher from Oxford, and what he said was he used it fortnightly to enhance productivity and for important intellectual challenges. So he wasn't using it for jet lag, he was just using it to get a good day's work in. And he got it via the internet. And he said it was a mild effect, but very valuable, and it increased mental energy and improved sustained hard thinking. So when Nature did their poll, they looked at 1,400 people from 60 countries. And really what I wanted to point out to you was that, you know, they found that 20% were using these drugs. But the other important thing is that when they asked people, they all thought, most of them, almost 100%, thought the people with psychiatric conditions should be able to use these cognitive enhancing drugs, you know, Alzheimer's disease, ADHD, and so forth. But then 86% of respondents thought that healthy children under the age of 16 should not be using these drugs if they were healthy and there was nothing wrong with them, they shouldn't be using them. Interestingly, here's where the coercion comes in. However, 33% of respondents said that they would feel pressured to give cognitive enhancing drugs to their children if other children at school were taking them. So that's also of concern, of course. So I think, you know, really concluding, I'd say that as a society, we need to consider which forms of cognitive enhancement, you know, pharmacological, exercise, lifelong learning, are acceptable, and for which groups, military, doctors, general public, under which conditions, you know, war, shift work, or whatever, and by what methods we would wish to improve ourselves and to have a flourishing society. And I've got some ethical questions there. It was quite funny because I was rung up to comment on whether we really use only 10% of our brains, and I said, no, of course not, that's nonsense. But because apparently they were pushing that in Lucy, that you only use 10% of your brain. So I want to finish in a positive way with 5 ways to mental well-being. So my favorite way is exercise. Exercise is great for your mood, it's great for your physical health, and it improves your cognition, your brain. In fact, if you exercise, there's neurogenesis in the brain, new brain cells, in important areas like the hippocampus. So it's a great thing to do. There's also mindfulness. You can take notice, be aware of things in the environment. If you focus on things and really enjoy the moment, you can get a sense of well-being from that. And keep learning, obviously, like you're all doing tonight, but I don't have to tell this audience to do that because I'm sure you do it all the time, but that's very good for you. And then connecting, having social relationships is important because that helps with your resilience. So having friends, family, and so forth. And then interestingly, when you give, it's rewarding. So donating to your favorite charity actually activates the area in the brain that's the reward system in the brain. So not only is it a good thing to do because you're giving money to charity, but you actually get this sense of reward, reinforcement in the brain. So I'll finish with that, and I'll push my books. Sex, Lies, and Brain Scans. That's a great book. It's been reviewed in Nature, and it's also got a prize from the British Psychological Society. This is a book I wrote before that, Bad Moves. And I hope that you'll all come to the Cambridge Science Festival event that I'm putting on. It's going to be on the, Kettle's Yard is opening now, and it's going to be in the new gallery, and I think it'll be lots of fun. So thank you very much for your attention.
Well, Professor Sahakian, that was absolutely smashing. Some deep science, some really serious implications for people in unfortunate situations, and some serious implications for people who'd like to improve their situation, which I find a little bit scary, and some good practical advice to end on. Thank you so much for that. Well, our usual arrangements, folks, if you try and catch my eye, if I like the look of you, I will point towards you and ask the splendid microphone operators to give you the means to ask a question. Sir.
Thank you. You didn't say anything about the side effects of these drugs.
Yeah. So modafinil has relatively low side effects, which is one reason, I think. That and the fact that it doesn't seem to have abuse potential as far as been examined so far, and it's been thoroughly examined. So I think the fact that it's got low side effects and really no or low abuse potential makes it a particularly attractive drug for healthy people to take. Some of the other drugs, like methylphenidate, I mentioned that some people can't take it because of the side effects, and sometimes people get palpitations, slight agitation, difficulty sleeping at night. And it's difficult to say, because sometimes that might just be that they weren't given, they were given too high a dose. They weren't given the dose had too many side effects. And I think I showed you with the two professors, we had one of them was using 200 milligrams of modafinil, which is what we find in our studies. We've looked at 100, 200, and 300 milligrams of modafinil, and 200 is the best dose for cognitive enhancing effects. And that's what the American professor was using, who's a medic. But the philosopher was using 100 milligrams, which is it was okay in our studies, but a bit low, didn't get quite the same effects. But, people have different sensitivity to drugs, so yeah. And obviously, the more virulent stimulants like Adderall have even a higher side effect profile.
The gentleman just here, then the lady in front, and then the gentleman in the red shirt, please. Oh, sorry, after you say it.
Some of the studies you addressed had relatively small sample sizes, so I'm concerned about the statistical power which is required to draw robust conclusions. Do you intend to replicate these studies, but then a larger sample size, perhaps on different groups?
Yeah, we do have relatively low numbers. Now we've got 40, 30 in groups, and that's not too bad. And 30 in the placebo, 30 in the control group, in the modafinil group or whatever. So it's not too bad, but we would like to have really large numbers, but it's just quite difficult. But people have done meta-analyses of the studies with modafinil, and they've shown that basically you do get moderate effect sizes for these studies as a whole. So you can aggregate all the studies together and then show that there's an effect with the larger sample size.
Gentlemen, patiently waiting over by the wall, please, and then the lady.
So you talked about the benefits of cognitive training. How long do those effects last after a training session?
Well, that's a good question. Some people have shown that they can last for quite a long time. There's some studies in patients with mild cognitive impairment that show that they can last quite a long time. We didn't look over a long time in our study, so we didn't do a follow-up. I wrote a paper for the BMJ called Use It or Lose It, and I very much believe that you have to use your neural networks in the brain and keep them activated in order to keep them functioning at their optimal level. So I sometimes get concerned about people who retire and then don't go out to learn new things, don't go to lectures like this, they sit at home maybe watching TV, because those are the ones who usually deteriorate quite fast. So my own view is that you really need to keep that neural activity going in the circuit. But I would imagine you'd have some carryover effects. But it's the type of thing, you'd play it for a few minutes a day and just keep doing it. And that's what I would recommend, yeah.
Thank you. I'm particularly interested in the potential application in Alzheimer's disease, where some of the concerns really wouldn't seem to apply much. As far as I'm aware, in mild to moderate Alzheimer's in the UK, it's normal simply for donepezil, which is good but limited, to be offered. And I'm wondering what the arguments are against Modafinil being offered, and also you referred to the platforms on tablets and so on for brain training. If somebody wanted to access these, how would they do it, and what are the arguments against?
Well, that's one reason we tech transferred ours via Cambridge Enterprise to the games company Peak, because they can just do an app and put it out there for sale. It doesn't cost very much, and you can put it on your phone. So it's a way to get it out there to lots of people. And so I think that's a very good idea. I mean, Modafinil is actually being used by some of our medics off-label for people with Parkinson's disease to treat their, almost apathy or lack of motivation. So like I showed that it improved task-related motivation, some people are using it as an add-on to medication like L-Dopa in Parkinson's disease, just for the individual, because you can do things for individual patient benefit, and some people at Cambridge do give it to patients on a named patient basis, just to facilitate their cognition and to improve their motivation if they have like Parkinson's disease or something.
And for Alzheimer's?
Well, I think the thing about Alzheimer's is you'd really want to use it in the mild cognitive impairment stage. I mean, I'm trying to get people to identify Alzheimer's everywhere, and I think, that's a really important thing, because if we can start to treat people at that stage, the effects will be so much better. I mean, it's like you think about physical health. Nobody would let themselves, if you knew you might have a cancer or something, nobody would just leave themselves for years before they got detected. But in mental health, they do it all the time. People, in this country, it takes about 11 years to get a diagnosis of obsessive compulsive disorder. So by the time you've had it for 11 years, you're quite ill, actually. So we really need to move to early detection for all these things. And when you think about it, we know from the studies of looking at Alzheimer patients that they already have a lot of plaques and tangles in the brain. If you do the beta amyloid PET studies, you can see that the brain's already quite damaged. So you want to get in there before the damage is done and be able to treat effectively while somebody still has mild cognitive impairment and they're still maybe working and they're certainly functioning within the home.
Thank you. You seem to be advising us to all go out and take modafinil. Have I misinterpreted you?
Well, yes and no. I don't think you should all go out and take modafinil, and I don't use it myself. But what I would say is that I think the government should get together with the pharmaceutical company and actually do a study to see if it's safe and effective in healthy people. And then if it is, it would be much better that people got it through Boots or some other chemist than that they had to buy it over the internet. I also think that it might be safer than what people are doing with caffeine, where they're using very large amounts, and there are some, side effects with caffeine and that are quite unwarranted. So I think it wouldn't be a bad idea. What does worry me is when I think, well, why are people using these drugs? Is the pressure on young people so great in this competitive age that they feel, they have to get ahead, they have to do this. So if it's just that, it's the stress and pressures of modern society, I'm very much against that being the solution. I think we should go out and exercise and think about a work-life balance and things like that. So I'm very glad you asked me that question, because I feel that we should investigate whether this drug is safe and effective in the long term for healthy people. But I do feel that we also need to think about ourselves as a society and how we see ourselves flourishing in the future. It's really important.
Thank you for your lecture. Is there work going on to determine how methylphenidate, for example, works at the level biochemically or physiologically at the level of neuron?
How is it working at the level of the neuron?
Yes.
So, well, these drugs are obviously acting through chemical modulation. So and that's why I didn't really have time to explain it, but obviously I'm very interested in these cognitive enhancing drugs for people with neuropsychiatric disorders, Alzheimer's, ADHD, and schizophrenia, but also for people with traumatic brain injury. But in my laboratory, to try to understand how the chemicals in the brain actually normally work in our brain to improve different forms of cognition, like attention, planning, problem solving, memory, inhibitory control. We use these drugs as tools, and that's why the more specific a drug is, the better it is for us as using it as a tool. So with Atomoxetine, for example, it works relatively selectively through noradrenaline. So if we see an effect on cognition, we can attribute that predominantly, probably, to noradrenaline. Whereas some of the other drugs, like Modafinil, is kind of mixed. It's got a lot of actions. So it's very hard to determine how that drug is actually exerting its cognitive enhancing effects.
Do you think cognitive enhancing drugs will ever be banned in competitive situations, or tests developed similar to doping tests for athletes to detect them?
In competitive situations, sorry, I didn't hear the very end.
Or tests developed similar to doping tests for athletes to detect them and prevent their use in these situations?
I mean, people have asked about that, actually, because they've, some of the media have said, should we be giving urine tests or something before people go into exams? And I mean, it's probably just not really very practical to do that kind of thing. But it is a competitive situation, and so, I know that some people feel concerned that people are using these methods, and they don't particularly want to, but they feel pressure. I mean, some of the students complain. And I suspect that's why Duke at least put that statement on their website, that if you use it in exams and you're not got a prescription for it, and it's a prescription medication, that's basically cheating.
I'm afraid we've got time for just two more gentlemen there and a gentleman there. And I'm sorry, a couple of people have caught my eye. I'm afraid we're not going to get to you, so hang around and perhaps try and catch Professor King before she goes home. But sir, please.
Hello, I just had a couple of questions. The first one was regarding the working memory.
Mm-hmm.
I was wondering, because the test and the games were very domain specific, like the games were exactly the same as the test, so the games were preparing you for the test that you were about to take. And I was wondering if after the games you tried other cognitive tests that weren't the same, and if it's banned.
Yeah, we do try tests within the same range, and they do tend to improve as well. There is obviously a relationship between the game and the test, but that's because it's the best test for episodic memory that I know of, because I created it, I think that. But also, it is the most sensitive test for detecting Alzheimer's disease. So and the idea was that we actually had the data on it and the data on the neuroimaging, so that we knew that if we could activate this neurocircuitry, we could activate the hippocampal formation, and therefore you get not only better working memory performance, but as you saw in the imaging data, you get the activation of that area, which is what we were trying to get. So I think the big important thing is that it isn't just restricted to that. So when you give, general functioning of everyday activities, you also get an increase. And you would expect that because episodic memory being so important for everyday functioning is coupled to activities of daily living. But it's important that you show that not only do you get the episodic memory change, but you get the change in the activities of daily living, which is much more global and some people might think relevant type of improvement.
Thank you. And the other question I was wondering about was, you mentioned with ecstasy that it caused depression later on, probably due to desensitization. I was wondering if modafinil has effects like that over time, that if you had taken certain doses, it would lead to desensitization over time.
Yeah, I mean, that's why we need these long-term safety and efficacy studies in healthy people, because we don't know in healthy people what the effects are. I mean, it is used in narcolepsy, and it seems to, I mean, that's, you know, again, as I said, it's being continued to use. There doesn't seem to be any effects like that. I think, I haven't heard of anything like that. I mean, people who I know who use it don't report anything like that.
Thank you.
How did the predictive performance of the AD cognitive test compare to other tests such as CSF tau? And what was the predictive power in general? So how early could you distinguish whether an MCI patient or a healthy control patient would go on to develop AD or not?
Yeah. That's a great question. So part of what we're doing with this biomarkers study, which is called the Medical Research Council Deep and Frequent Phenotyping Study, is to try to look at all the biomarkers, all in one study, to see which is the best predictor. But what I can say is, I showed you a whole range of studies that we've done over the years, and one of those studies was done in collaboration with Oxford. I know we don't usually collaborate with them, but we did on this occasion. And what we did was look at healthy elderly people, and we gave them the CANTAB PAL test of episodic memory, and then we followed them up, and we found that it was predictive of those who went on to decline and get Alzheimer's disease 3 years later. So it was very good at identifying a small group who was doing very badly, who then went on to get the diagnosis. So I think it's very, very sensitive, but at this stage we can't say, you know, I mean, so far it looks more sensitive than a lot of the other markers, but as you know, we haven't really been looking at some of the other markers except in defined Alzheimer's disease. So the question really is, and we know that some of these, the pathology starts well before the diagnosis occurs. So it may be that the pathology is starting, you know, in the 40s or something like that. I mean, probably the youngest patient I saw was with Alzheimer's disease was about 57, but there are younger patients. I mean, you can. So I think the point is we don't have anything where we're looking early enough, probably yet, to see. You need to do that in a massive, just healthy population, and then follow them up for some years and see which one is the best predictor, which would be a great study, but quite expensive.
Thank you.
Well, Professor Sahakian, thank you. That's absolutely super. I'm apologising to the people who I didn't manage to bring in for questions, but I think that's a measure of the fascination with what you've been talking about. I think this link between the deep science, as I mentioned before, but also turning that into practical things that people can do, and indeed in due season perhaps we may be able to analyse ourselves more effectively, and the idea of spotting the Alzheimer's before it gets too far seems to me absolutely fascinating. Altogether an outstanding and very CSAR-ish, so you sound what I mean, CSAR-ish evening. Thank you very much indeed.
Thank you. Thank you.